platform of KTCT College of Arts and Science, Kallambalam. I am RESHMISREE UV, HOD, Department of Mathematics, KTCT College of Arts and Science, Kallambalam. Let us start about studying real numbers. Before studying real numbers, we are going to define how real numbers came. We have studied about numbers from our KG classes. First, we have studied about the natural numbers. So we begin with the natural numbers. What are natural numbers? Natural numbers are 1, 2, 3, 4, 5, etc. Okay. We will write these natural numbers in the set n. N is equal to set of 1, 2, 3, 4, etc. Okay. Here we can perform addition perfectly well. For example, 2 belongs to natural number. 3 belongs to natural number. Then 2 plus 3. What is 2 plus 3? 2 plus 3 equal to 5. That also belongs to the natural number n. So, addition is perfectly done in natural numbers. But how to define subtraction in natural numbers? How to define subtraction? For example, 4 belongs to n, isn't it? 3 belongs to n. Then 4 minus 3 equal to 1. That also belongs to n. Okay. Now another example. 2 belongs to n. 5 belongs to n. Then what will be 2 minus 5? Yes, 2 minus 5 equal to minus 3. That does not belong to the natural number set. So addition is perfectly well done with natural numbers. So we cannot subtract natural numbers. Can subtract natural numbers, but that does not belong to the natural number set or set of natural numbers. Here minus 3 does not belong to the set of natural numbers. So, to define subtraction, we must extend our system to the integers. So, what are integers? Integers is denoted by the letter Z, etc. Minus 3, minus 2, 1, 0, 1, 2, 3, etc. Okay. So, here subtraction is possible, addition is possible, and the number 1 plus 0 equal to 1. Additive identity. 0 is called the additive identity. Here the additive identity is possible, and we can find an inverse, that is 1 plus minus 1 equal to the additive identity element 0. So in the set of integers we can find the additive identity and the additive inverse. Can we find multiplicative identity in this set? Yes, absolutely. 2 into 1 equal to 2. Any number multiplies with 1 equal to that number. That also belongs to the set Z. So multiplicative identity is defined in here. But in order to define the multiplicative inverse, this set of integers is not sufficient. So now look at an example. What will be the multiplicative inverse of 5? What will be the multiplicative inverse of 5? That is 5 into a number equal to 1. We all know that 5 into 1 by 5 equal to 1. Okay, 5 belongs to Z. But this 1 by 5 does not belongs to Z. So we extend our number system to find the multiplicative inverse. That system is the set of rational numbers. So now what is rational numbers? Rational numbers is denoted by the letter Q, that is equal to set of all P by Q, where P and Q are integers. P, Q belongs to Z with Q not equal to 0. Okay, so to define inverse, we extend our system again to rational numbers, that is Q equal to set of all fractions P by Q, where P and Q are integers and Q not equal to 0. So these are the numbers which is contained in the real number system. This along with the natural number, integers and rational numbers, we can extend the number system into new system, that is a real number system. Now some properties of real number system. First property is a field property. What is a field? Field property. So field is any set where addition and multiplication is defined, are well-defined operations. In addition to the well-defined operations, certain properties has to be satisfied. First property is commutative property. What is commutative property? Here the well-defined operations are addition and multiplication. We know that 2 plus 3 equal to 5 and 3 plus 2 is again 5. Whatever be the order, if we interchange the orders, we will get the same answer. This is the commutative property of addition. Same property is satisfied for multiplication. We know that 2 into 3 equal to 6 and 3 into 2 equal to 6. And see, if we interchange or multiply for addition and multiplication, we get the same result. So for every A, B belongs to R, A plus B equal to B plus A and AB equal to BA. Okay. And this property is called commutative property. So field must satisfy the commutative property of addition as well as multiplication. Next property is that associative property. What is associative property? Here we have to take 3 numbers, 2 plus 3 plus 5 equal to 2 plus 8 equal to 10. written. Now 2 plus 3 plus 5 equal to 5 plus 5, that is again 10. Okay, here we first add 3 and 5, then add 2. In the next step we add 2 and 3, then add 5. We get the same result. This property of numbers is called associative property. This is true for multiplication also. So when we multiply these two numbers, we get, now let us check for multiplication. 2 into 3 into 5, 3 into 5 equal to 2 into 15 equal to 30, isn't it? Now 2 into 3 into 5 equal to 2 into 3 is 6. 6 into 5 equal to 30. Okay, 6 into 5 is again 30. So this property of number in addition and multiplication is called associative property. So if there are three numbers A, B, C, then A plus B plus C must be equal to A plus B plus C. Similarly, A into B into C equal to AB into C. This property is called associative property of real numbers. Next property is the identity property. So what is the identity property and what is the inverse? Now what is the identity? We know that 2 plus a number equal to 2. Which number will add to get the answer to? Yes, it is 0. So if we take any number adding with 0, we get the same number. There is no change to that number. That number is called the identity number. Here the additive identity is plus 0. Okay, so again we get 2 plus a number equal to the additive identity. What will be the number? Yes, it is minus 2. This minus 2, a number with a negative of a number, is we get an identity. That negative number is called additive inverse. This is true for multiplication also. For example, 2 into a number equal to 2. Which number we multiply to get the answer to? Yes, 1. So the multiplicative identity is 1. And 2 into a number equal to 1. What will be the number? It is 1 by 2, isn't it? So 1 by 2 is called the multiplicative inverse. So in real numbers there must be an additive identity and every element must have an additive inverse. So same thing for multiplicative identity and multiplicative inverse exist for all non-zero elements. Next property is the distributive property of multiplication over addition. Next property is the distributive property of multiplication over addition. In this property, we can distribute multiplication over addition. 2 into 5 plus 6 equal to, what will be the answer? 2 into 11 equal to 22. Now 2 into 5 plus 2 into 6, what will be the answer? 10 plus 12, that is also 22. That is A into B plus C equal to AB plus AB plus AC. Here multiplication is distributed over addition, over this addition. Okay, this property of real number is called a distributive property of multiplication over addition. When all the properties of these 6 properties, okay, satisfied, we call that set is a field. Okay, so a field is any set where addition and multiplication are well defined operations that are commutative, associative, that is commutative. Next is that is commutative, and next property is associative, and third property is there must be an identity, additive identity and additive inverse, same, and multiplicative identity and multiplicative inverse. And the final property is distributive property of multiplication of over addition. Okay, when all these properties are satisfied, then that set is called a field. So now we are going through the examples of field. Q satisfies all the properties of Z, or properties of field. Sorry, Q satisfies all the properties of field, but neither Z nor N is a field. Why? Neither Z nor N is a field. Why? We know that the multiplicative inverse of 2 is 1 by 2, but 1 by 2 does not belong to Z, so multiplicative inverse does not exist in Z, so it is not a field. And in N, additive identity of 5 is minus 5, isn't it? But minus 5 does not belong to N. Also, the multiplicative inverse does not belong to N. Hence, N is not a field and Z is not a field. And the finite set 0, 1, 2, 3, 4 is a field when addition and multiplication are computed modulo 5. Another example for field is the finite set 0, 1, 2, 3, 4 is a field when addition and multiplication are computed modulo 5. That is when we divide a number by 5, the remainders must be 0, 1, 2, 3 and 4. So that property also satisfied commutative property, associative property, distributive property, additive identity, multiplicative identity, additive inverse and multiplicative inverse. So we can say that Q is a field, and we extend this to natural numbers, real numbers, and real numbers is also a field. Okay, so if we take any two rational number, for example, if we take R and S, then exactly one of the following is true. Either R less than S, or R equal to S, or R greater than S. Either these three will happen. If you choose R and S, either R less than S, or R equal to S, or R greater than S. For example, if we take 1, 2, then 1 less than 2. Okay. Then if we choose the number R equal to 1 and S equal to 1, then 1 equal to 1, either 1 less than 2 or 1 equal to 1. If we choose R greater than S, so if we take R is equal to this and S equal to this, then R must be greater than S. So either these three are happen. Either one of these three are happen. Such a property is called order property. The set Q has a natural order defined on it. That is, Q has a natural order. Okay. So Q can be otherwise called Q is an ordered field. In the same manner, we can say that real numbers is also an ordered field. Okay. These are just the introduction about the real numbers. So in the next class we discuss about the irrationality of numbers. Okay, thank you.